I had to get the live stream going there. Well, awesome. Well, thank you all for joining us for our next session of Global Entrepreneurship Week. We're really excited for this conversation with Dr. Amakuchi and his work at OneBio, and also just his pathway into entrepreneurship and creating a business. But for this session, I think this is probably like our 12th or 13th event of the week so far. If you're not familiar with Global Entrepreneurship Week, it's a global celebration of the role entrepreneurship plays in our community. One, creating thriving communities through job creation and solving our world's problems, which I look forward to diving into the problem that they're solving at OneBio. Just wanted to give a shout out. So thank you, Dr. McReynolds, for the partnership on this event and helping identify our awesome speaker, which we'll be having a conversation today. And thank you, College of Natural Science and Mathematics, for the partnership. So, and all of you for being here. So, in kind of hopping into our conversation, one, you didn't have necessarily a straight path into science. One, you had a really unique background in kind of the culinary space. And so would love for you to kind of just share a little bit about like your pathway from culinary into UC Davis, and then ultimately kind of how you stumbled upon the research at OneBio, and then we can dive into what OneBio is all about. But thank you for being here, and looking forward to our conversation.
Great, thank you. I also want to say thank you to Kathy for giving me the invite. It's been great. I think it feels like we've been working together for years now, because I just keep hiring your students every single year. So I feel like there's some kind of connection there. But it's great to be here and to talk to everybody. But yeah, as you mentioned, I was not your traditional student that exited high school, went straight to a college or university, and started going after science, or at least chemistry. I grew up in a town that did not have a huge push for college. We were more of an agricultural community. So the idea of like understanding what chemistry was and what you could do with chemistry was like the furthest thing from my mind at that point. So right after high school, I knew I really liked to cook. So I moved out, Sacramento area, and went to school over at American River College. And I started going through the culinary program there. And as we got like deeper and deeper into it, I really fell in love with cooking. I'd always liked it. I was working in a restaurant at the time. So I was like, during the day, I was at school taking my classes. In the evening, I was in the restaurant working, and it was basically like doing two jobs. So I understand how difficult it can be for those of you that work and go to school at the same time. But along the way, I remember there was like this one class in one of my baking classes, and the instructor was talking about how starches can gel and things like that, and how that related to structure in baked goods. And I remember that, the science was way over my head, but I was like, wow, like people actually understand how this stuff works. And that was kind of like this moment for me that I started to say, well, maybe I should take some science classes and get an associate's degree instead of just a certificate. And so I took some early nutrition classes. I had to actually take remedial high school chemistry because I never took it in high school. So I took my first chemistry class, and I was always a bright kid. I didn't apply myself that well in high school. So I was kind of one of those students that would like show up and get B's, and that was like good enough. Like I didn't have to study that hard. And that first chemistry class like kicked my butt. Like I had no idea what I was getting myself into. I learned that I didn't know how to study. I didn't know how to like take things serious and problem solve and troubleshoot. And at the end of the class, my teacher came up to me and she's like, Matt, I know you're in the culinary department. Your grade is a D+. I'm going to give you a C. That way you don't have to take this class again. I just don't recommend you take any more chemistry moving forward. So that was a little bit of like a challenge to me. I was the kind of person that was like, well, I'm not going to let that person tell me what I can and can't do. So I immediately signed up for the next chemistry class, which was the first semester of general chemistry. And even at that point, I went through probably a full year of general chemistry before I understood why do people study this? Like, it doesn't seem to make sense. Like, what are the applications? Like, are people just doing this to understand more about the world and like how things work, but not really doing it to solve anything? And I think I just really didn't have the context of like what you can do with chemistry and how much it's ingrained in our whole world. And so I think that things like this are super, super useful to help students see like what kind of jobs are out there and how they can apply the things they're working on in ways that aren't immediately apparent. But so after that, I actually did pretty well. I got A's in my next couple chemistry classes and ended up learning that there was this thing called food science. And this sounded kind of like the dream to me. I was like, cool, like I finished my culinary degree. I was still cooking in the restaurant. I had taken all these science classes, and the idea that I could kind of put these two things together was like really exciting to me. So I promptly found out you can do a transfer agreement, and I transferred over to UC Davis because I happened to see that, hey, they have the best food science program in the world, and it's 20 minutes away. Like that seems like the right fit. So I went over there and took organic chemistry classes, inorganic chemistry, physical chemistry, and just kind of kept getting deeper and deeper into it while also taking all of these food science classes around microbiology and food engineering and things like this. And along the way, I took one class with a professor named Bruce German. And Bruce German is one of these professors that can make you fall in love with anything that he talks about. The way that he talks and inspires people is there's nobody like him in the world. And he was talking about his research in one of my food chemistry classes. And it was about this really unique interaction between a class of compounds found in human milk called oligosaccharides, or human milk oligosaccharides, and how they actually did nothing to feed the infant, but instead ended up feeding the infant's gut microbiome. And this was probably about 15 years ago, when like the field of the microbiome was not such a hot topic as it is today. And you mentioned the word microbiome to somebody and they had probably never heard it before. And just kind of learning a little bit about all of these benefits that the infant was receiving by consuming these oligosaccharides, these essentially fiber, indigestible sugars in the mother's milk, and how it nurtured the microbiome, they found that infants were having less incidences of colic, for example, or less incidences of pathogenic infections causing diarrhea. And also the infants were even starting to grow up with less incidences of allergies and asthma and things like that. So it like really inspired me. I asked the professor if I could join his lab and start doing undergraduate research, and he said yes. So during that time, I started to really dive into a tool called mass spectrometry. I don't know if many people are familiar with it, but it's a way for you to look at what types of molecules are inside what types of foods, milk, solutions, blood, serum, fecal matter. And I started studying all of those things. And so I started working and trying to understand how different metabolites in breast milk would interact with the infant. And I was getting towards the end of undergraduate, and I was just so enamored with this thing called research, that you could actually just like design studies and solve problems and answer questions. And I felt that I was just, even after 2 years of it, I was really only dipping my toes into research. And I was like, well, I guess I should go to grad school so I could learn a little bit more about what this research thing is and how it works, and continue to kind of grow in that way. So I asked Bruce German in the food science department if I could continue with him, and he told me absolutely not, that I needed to go work under a real chemist. And he introduced me to somebody in the chemistry department named Carlito Labria. And Carlito Labria was actually the professor that led a lab to discover the structures of all of those oligosaccharides in human milk. So it was a really good fit, and mass spectrometry was his main tool. So, around that time, I had like summer break, and one of the postdocs in my undergraduate lab was telling me that, hey, you shouldn't just go into a lab and just do the research project that's given to you. You should spend the summer and think about like, what is it that you really want to study, and what is it that you can answer that nobody's answered before? And even more important, what is the question you can ask that nobody's asked before? And so I had all sorts of ideas, and I sat and I thought and I thought and I thought, and it was actually like an exercise in thinking. I sat down with paper and wrote out ideas and, started to do research with other papers about it. And kind of the area that I settled was, well, food has fiber, and we know that fiber has impacts on the microbiome. Your gut bacteria consume it. But really quickly, I started thinking, not really quickly, it was a lot of work, but I started thinking about, well, what happens to the infant's microbiome when you're no longer feeding them human milk? You're now feeding them plant fibers. So all of a sudden, the structures of those oligosaccharides, of those carbohydrates are changing, and that must drive different communities in like an ecology sense. And I had the idea that I was going to use all those same tools that were developed for the human milk oligosaccharides to start studying what happened in infants. So I joined grad school. I ended up writing a grant and getting it funded with some collaborators that we were going to do the first weaning study where we actually controlled the first food that an infant would receive after being exclusively fed breast milk. And we were like, okay, if we're going to do this, we should look and see, let's pick two foods that have completely different structures of fiber so that we can get very different responses in the microbiome. And at that first moment there is where we learned that this plan that we had going was going to be a lot harder than we thought it would. Because all of a sudden we started digging into USDA databases and papers and things like that, and we found out that nobody had actually cataloged what kind of fibers are in what kind of foods. So if you look at the back of a nutrition label, it says soluble and insoluble fiber. But we don't talk about vitamins that way. We don't talk about vitamin A, vitamin C, vitamin K, and B12 as if they were just this black box of things that are good for you. We know that each vitamin has a very specific purpose in your body, and your body metabolically uses it differently to help provide you health. And so from that moment, we said, well, maybe the first thing we should do is just like find all the baby foods that we can and just see what kind of fibers are in them. And we started to do that, and we tried to use those same tools for the oligosaccharides, and we found that it simply didn't work. I broke a lot of instruments trying to inject insoluble material onto HPLC columns and things like that. But ultimately, we found out that these things were so large that you had to find a way to chop them up into pieces. And so I spent the next couple years developing methods to rapidly characterize what types of fibers were in foods. And at that point, we were getting a lot of funding from Mars, the candy company. They own pet food. They have other non-candy foods as well. They're a global food company. And we were at a dinner with the chief scientific officer of Mars and my professor, Carlito, and a couple grad students. And we were talking about this with them. He said, hey, we're working on this project. We're doing this thing. We're trying to characterize all these foods. And I remember it was like this moment we had like the first bottle of wine had been drunk at dinner, right? And the professor, my professor was like, yeah, we're gonna characterize and write a paper about the fiber structures in 100 foods. Like, okay, yeah, we can do that. And then like the second bottle of wine came around and it was, we're gonna do 500 foods, right? And then by the end of the dinner, we were at the third bottle of wine and it was, we're gonna do 1,000 foods. And I remember being the grad student that was gonna have to do that. And I was like, oh no. But the very next day, I went out and I started bringing undergrads into the lab and trying to find as many people that wanted to learn about this as possible. And I was sending them out to farmers markets, to Asian grocery stores, to Mexican grocery stores, to Indian grocery stores, and just buying as many different food products as they could. And we eventually did that. We built up this library of 1,000 foods that we'd actually gone and structurally characterized, sugar by sugar, linkage by linkage, what the structures of those fibers were. Still one piece that we couldn't solve, and it was actually how those molecules were spatially arranged. So, if we think about sugars such as like glucose or fructose, are these polymers glucose, 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 or glucose, fructose, or glucose, fructose, and it was very complicated. So we started playing around with different techniques to actually break these things down into pieces that were small enough we could treat them like these human milk oligosaccharides, but big enough that we retain that structural information. And we tried all sorts of things. We tried base treatments, we tried acid treatments, and at one point we were into using oxidation. And we found this paper that was actually like the only paper I'd ever found that talked about the oxidation of carbohydrates by something called Fenton chemistry. And it was actually a paper published by the Smithsonian that was talking about how the places on old documents that ink was written seemed to degrade faster than the rest of the paper. And paper is made out of cellulose, which is a carbohydrate polymer, and a lot of these inks had different types of metal inside them. And the way Fenton chemistry works is hydrogen peroxide and metals together, causing the degradation of these carbohydrates. So we started this undertaking that we were going to try to see if we could get this Fenton chemistry to work, not on a piece of paper, but instead in a flask. Not even a flask, a small little tube. We were working with about the size of like one tear, so about 40 microliters of volume. And tried lots and lots of things, and I just couldn't get it to work, And one day, I accidentally prepped too many tubes. I had this experimental design. I was going to do 8 different concentrations of peroxide, but I accidentally had a 9th tube all prepared. So I figured, oh, that 9th tube, I'll do something crazy. I'll just put the concentrated peroxide in there and see what happens. And sure enough, it was that one tube that ended up breaking these fibers down into pieces that we could actually start to observe. And that was like a really enlightening moment for us. And we ended up filing a patent on the technology within the university. And pretty quickly after that, we started thinking, well, how could we commercialize this and what would the applications be? Originally, we were thinking we could have a service where we would characterize fibers for other people, but one of our collaborators in the microbiology department said, well, you don't just have an analytical tool here. What you have is a way to make oligosaccharides that nobody's been able to do before. So why don't we just make oligosaccharides out of as many of these fibers as possible and start testing what they do to the microbiome? And so that was kind of the aha moment. That was the moment we said, whoa, we could actually maybe create a company to do this. And these fibers, when they're smaller, they can start to be formulated in ways that people actually want to eat them. A lot of us don't like to eat fiber in our diet. Only 5% of Americans get enough fiber daily. And more than half of people get less than half the amount of recommended fiber. So it's actually like the biggest nutrient deficit in the American diet. Europe doesn't do much better. So it's not a discretely American thing. But the idea is once you can actually break these down, they don't have these gritty and gummy textural properties that you might be used to with fiber. Now you can put them into beverages, you can put them into food products that people are already eating. So this was kind of like the hypothesis for the company that went through several names, and we're now on the name One Bio. And so, yeah, that was a little bit of my journey. It went really long, but
no, that was good. I left it open-ended for that reason, for you to tell the story. And just all the science is over my head, so it's ironic that I'm probably the moderator, not knowing all the science. So I'm gonna pull out a couple of I think the mindset things for me was like, one, just kind of this focus on like solving problems, which was really kind of the entrepreneurial mindset for me, was like that teacher who said, no, you're not going to be a chemist. And you're like, you know what, I'm actually gonna double down and go pursue that. And then kind of this intellectual curiosity is how I'd put it, was just like the wanting to ask the right question, which I think is key to any innovation and entrepreneurial pathway. And then this lastly was, opportunity, and when opportunity presents, to kind of to take that next step along that. And that happened at a variety of stages, from seeing the connection from culinary to culinary science, from then like, I think I feel like a lot of those innovation stories is where it's like something random that someone does that kind of breaks into that innovation. And so would love to kind of pivot the conversation to, you formed the company, and you have the patent and the innovation. What did that look like in there's a shift in mindset that has to take place of like, okay, we're going to take this and try to commercialize it, for one, and kind of how did you surround yourself with like a team to help build that, and kind of, so one, kind of like looking at it from a team, and then also like, how does that actually just kind of work in shifting from the mindset and growing just innovation into an actual business?
Sure. I think that one of the first things that I recognized, and I think that some founders of companies don't recognize fast enough, is that if we're the technical expert, we're probably not the market expert. So you get a lot of founders that want to be founder CEOs. You get a lot of founders that want kind of that title and things like that, that I'm the CEO, I'm the person running this company. I very much knew that I did not know the food industry the way that people do. I did not know how to build a company the way that other people that have done this before did. So one of the first things we did is started trying to build the right team. So in the very early days of the company, we brought on a CEO. He had started several companies kind of in the life science area, mostly in diagnostics. So not really food related, but he did have a food science background. He had done diagnostics for different types of cancer and things like that. So he was familiar with the analytical technology of the company and things. And the very next thing we did was bring in somebody that would specialize on the business side that had actually worked in the food industry for most of their career. So these are two established people that we were able to get on board just by talking about the vision to them. We were able to put together some funds fairly early. We got a grant of fairly reasonable size from the Bill and Melinda Gates Foundation, who we'd been kind of working with while we were developing the research in the university, and they were really excited about kind of helping launch this and things like that. So, you know, we got some of that early money, and you're not going to be able to hire people if you don't have money. So that's probably the hardest thing about getting a company going is like, how are you going to get that first bit of capital? Like you yourself might be able to be like, oh yeah, I'll work for free. I'll do this on the weekends and nights and things like that to make this happen. But actually recruiting people, like you need money to pay them, or else they're just not gonna join. So with this team, we actually went out and started kind of developing the business model, developing where the technology fit into that. We ended up filing another patent or two early on. I think it was 2. And that was enough for us to go raise our first round of financing. And so this is where we went out to different venture capital companies, and we pitched them the idea, we pitched them the value opportunity, what markets we were going to go into, who the customers were going to be. And then, you know, my job was to make sure that they were confident that from a technology standpoint that we could get there, you know. And so from these very early companies, like the technology is like, it's very muddy. Like you have an idea, it seems like it's working. I can tell you that like there was so many times while I was in school and even right after that I was like, wait, is this technology, like, is this thing actually working? Is it not working? Because like yesterday I got these results and today like I'm getting different results here. And so it's just trying to like de-risk all of those for those people that are going to invest in you. You know, if you're a very early company, they're not going to expect that the technology is super sound. They're going to expect that you can bring it to a point that it will be sound. And I think that that's what we were able to display from those very early days. Yeah, and then when we got some of that financing done, we brought on our first 2 employees, and one of them was a Sac State grad, a master's student from Kathy's lab, Corey, and he jumped right in, and he was actually an organic chemist, which I was not. I was more of an analytical chemist. So he brought all these like additional ideas and expertise to the table that were able to like take away a lot of that muddiness and a lot of those struggles that kind of were happening because I was trying to work in an area that I wasn't necessarily an expert. So when I brought Corey in and some other folks, they started to solve those problems.
Love it. And I know just from prior conversation, I think you have 8 or 9 or more Sac State students as part of the team. So a growing effort there. So would love to kind of like when you started that process of like formalizing it into kind of going into the market, what were some of the challenges that you had in maybe interfacing with the university or just, the team in general, which, oftentimes we're creating, patents and innovations that then maybe don't have market applicability, whether that's tested or not. And so we'd be curious to learn a little bit more about what those challenges have looked like and then maybe resources or things that you've navigated personally or as a team to get there.
Right. Yeah. One of the first challenges, like the university entrepreneurial system can be actually really, really helpful. They have all sorts of people they can introduce you to. They have templates for documents and things like that that you can use for your first like employment contracts and things. And they're super helpful. But then at some point you have to actually start dealing with like the university innovation department. And this is where we were trying to actually license that patent that we wrote in the university back into the company. So it became a very strange moment where you're sitting across the table from the university and you're like, man, I developed this technology. Like the professor whose lab I did it in is a co-founder of the company too. Like this, why is this so difficult? And the university is wanting to get a good deal too. Like the University of California has like their most, like one of their biggest streams of income is a patent on a strawberry variety. And they bring in like millions of dollars a year just because of the royalties that they got for licensing that patent out to people. And so, we had to sit across from the university and negotiate what are the terms of this patent? Like what are the royalties the university will get on any profit that we make and things like that. And so that was like the first like really uncomfortable moment in the company is like standing there in front of the university and being like, well, like if you don't license this to us, like we'll go figure out a different way to do it. And like having to like have that stance, right? And like having to like go back through your own patents and be like, well, where are the gaps? Like where did I leave holes? Where are the places for opportunity there and things like that. But ultimately, we did end up coming to like a really good place with the university, and I think both sides are happy. We were able to structure things in a way that it didn't take too much away from us, especially in the early days where we were more vulnerable as a company, and they were able to get what they wanted in the long run. So in the end, it ended up happy, but I'm glad again that our head of business development at the time had been through these negotiations before. He knew what standard rates were. He knew what kind of deals the university was doing with other companies. So that was super helpful.
Awesome. Yeah. So surrounding yourself with the people who've been there and can help with that process. For sure.
Exactly.
So when you're kind of looking at OneBio and kind of where you're going next, what's kind of the next milestone, both from maybe like the science side of it that you're working towards, if you can share those things, and then also from like a business side, what are some of the milestones that you're working towards next? So that kind of next level of success for OneBio.
Yeah, there's a lot to unpack there. From the science side, over a couple of years, the company's been around for almost 5 years now. We really developed that technology at the bench scale. But we're moving to a point now where we need to actually make this industrializable. Like we no longer can make 100 grams of these oligosaccharides for testing, but we need to make kilograms, and very quickly we need to be able to make tons, right? And you get hundreds, thousands of tons. And so for the last year and a half or so, I've really been focusing my time on building the right team to do that scale up. And so this is a team of engineers, chemical engineers, that can go and take basically what we're doing at the bench scale and converting it to something that works industrially. And that's actually like a huge, huge challenge that I think people oftentimes maybe underestimate. They think that the challenge is in the innovation and trying to get something to work, but like there's just as much, if not more, challenge in trying to get something industrialized. And so, yeah, spending a lot of time hiring a team towards that. We're actually right now, we have a functioning pilot plant. We have half of that team is from Sac State, actually, and they're making tens of kilograms of these fibers. And we're starting to put them through the regulatory process. So our first fiber is actually a fiber that's coming from barley, It's called beta-glucan. And this fiber we found is actually able to interfere with the metabolism of starch. So it can actually be used to reduce the blood glucose spike that people get after meals. So we're targeting this to be a product for diabetics and pre-diabetics that are trying to better manage their blood glucose levels. So right now we're going through the regulatory process called GRAS, which is generally regarded as safe. And this is like basically the regulatory system for a new food ingredient. So we've actually done most of the work there. We're waiting on some results of a stability trial. You have to show that you can produce the material reproducibly over a number of batches, and that you don't have any contaminants or microbiology concerns that are going to get people sick. But you also have to show that there's shelf life of this product, that it's not going to go bad on the shelf. So right now, we're in the middle of those stability trials, and we should be getting that data back probably in the next month, and we should hopefully have our first product approved through regulatory in the first couple months of the year. On the other side of things, we really found that we were getting to a point where we needed to kind of up our game on the business side. So our former CEO that helped us start the company, his expertise really lied in that, like, how to get technology going, how to get the right team in place, how to get lab space, and how to build a company in that way. And he himself, it was really great because he recognized that he was not the right person to lead the company into a more commercial phase. So it was a very nice point for us to actually go out and start hiring a CEO. And so he stepped into the president role. So he still works for the company, and he likes his new job a lot more than he liked his old job because he doesn't have to work with investors nearly as much. But we brought on a CEO about 6 months ago by the name of Matt Bernard, and he had very successful exits within the food industry. So this is a guy that has like raised billions of dollars in capital from investors. And this was like when he first said it to me, I was like, oh, with a B, like that's a lot of money that you've raised. So his last company was a company called Plenty, which does indoor ag. So it's the biggest indoor ag company. So things like indoor strawberries and lettuces and things like that, grown very, very efficiently. They had to develop their own light bulbs in order to like convert energy at the cheapest cost, because that's what their business model was all built on. But we brought him in about 6 months ago. That recruiting process took about 6 months on its own, because when you're bringing people like that into the company, the paycheck is not what they're after. Like these people, they've built successful companies, they've made money. They now want to make sure that they're working for companies that they think they can make large impacts on the world. So we spent a long time with him talking about what are the potential opportunities that we present and where our struggles are and where he could come in and help. So 6 months ago, he came in, started hiring a commercial team. So now we're hiring MBAs and folks that know how to do marketing and understand what consumers are looking for and think about product. So now instead of me thinking about fibers and oligosaccharides, they're thinking about, should this be launched as a gummy? Should this be launched as a soda? Who is our partner? Because we're what's called a B2B company. So this means that we're not selling directly to consumers. You'll probably never see a OneBio soda or something like this, but we'll sell the ingredients to the folks that already are. So who are the right customers that we should be going after? Who are the right partners that we should be launching with? And so that's really where we've been kind of focusing on those two avenues. And I'd say overall, I would call this commercialization.
Yeah, that last point definitely really struck with me, because I think, just sitting up here and listening to the science, I could see like, oh, I this might be a product, but I don't know the like science behind it, right? And so has there been, as that like new department, I guess is maybe the term, has come on, what has that looked like in terms as a team and maybe the communication back and forth and helping them understand the innovation and science behind it, and then saying maybe this is how it should be positioned to the market? Has that been an easy process or tension, or how does that look like in the communication process across those different brains, I guess, for lack of a better term?
Well, everybody told me it was going to be a process full of tension. Everybody said all of a sudden you're going to bring in a commercial team and they're going to be the priority and the science is going to be on the back foot. And I will tell you that I felt now 6 months later that that's like 100% the opposite. Like it's been absolutely fantastic working with a very experienced commercial team, because now no longer like am I the one that has to answer these questions when investors are asking about like, what's your path to market? Like how many sales do you envision by this time? And it's like, I don't know how to do that stuff. I'm a chemist. I'm not, I haven't taken business classes. I don't know how to do these things. Like I felt always very uncomfortable trying to answer those questions. But now having a team of people that, number one, fully trust myself and my teams as scientists, that they, when we tell them like, hey, like we've hit some roadblocks, we're gonna need like a couple extra months to figure this thing out, there's gonna be delays, like there's no pushback. They're like, okay, we get it. We know that you guys are doing what you do best and these things happen and we trust that you're gonna get over them. We're gonna keep doing the things that we need to do. So it's actually been really, really good working with commercial teams that, number one, have trust and respect for the scientists in the company, but number two, are like prepared to dig in, prepared to hit that learning curve, and like prepared to answer those hard questions.
Awesome. Yeah, just focusing on each of your strengths. I love it. So I'll ask one and then would love to have the audience ask some questions as well. So if you were to kind of go back to, your undergrad and then kind of into your graduate studies, how might you have prepared a little bit more for the journey that you ended up going on if you're now looking back at it? Are there, experiences that you might have sought out or different things around that space to better prepare yourself?
I think I wouldn't have done anything different. I think that kind of the path I took brought me to this place, and if I took another path, I might have ended up somewhere completely different, maybe better, maybe worse, maybe the same, but I'm really happy with the path I'm on. But things I can like recommend to people, I can maybe talk about that. And I think that part of it is like being able to think interdisciplinary is like really, really big, right? Like being able to think about, for me, it was being able to think about food as like a chef and as a food scientist, but then able to think about at the same time what's happening at the molecular level with my chemistry background, right? And understanding that like these things don't happen in isolation. Like you oftentimes, have chemists that are like really digging into the chemistry of something, and then they forget that like, oh, this is like a food system, and like some of these problems have already been solved. There was a time we were trying to purify barley, for example, and man, we kept getting this like really thick, fibrous material at the end, and everybody's like, what is this? What's happening? And when I saw it, I like remembered back to my culinary days when I was making something called seitan, which is basically just gluten. And so I was saying, oh, that's gluten. I've seen this before. Like we can't forget that, we're working with something that people use to make bread. Like there's a reason that these things are binding together and things like this. And alternatively, there's things that food scientists miss. There's things that they look at and think, that's kind of actually how the whole fiber and health had been built, was by food scientists and nutritionists that often thought, oh, apples are good for this, but they never thought about like, well, why? Like, what is the fiber that's in that apple that helps people better, manage inflammation in the gut? Like, what is the structure of it and why does it do that? I mean, we wrote a whole paper called Structures Without Functions. There's like a little bit of an editorial piece where we talked about how the carbohydrate industry was like looking at fibers as if they were just a structural black box, and that didn't matter. But everything else in biology and chemistry is very, very structurally defined, and we know that structure drives function. All
right, what questions do you all have? Just got it. Yeah, Laura.
So I have a question. You guys got some grants that Bill and Melinda Gates. How did that come about? Who filed the grant application? Did you guys have to do that yourself? Like, it seems like something hard.
So the labs I came out of in graduate school had a long-standing relationship with the Bill and Melinda Gates Foundation. They had funded the lab over many years. So we knew the head of their kind of microbiome and health division because we'd worked with them for a long time. And when we were starting the company, we were like, hey, like we're going to start this company. Is this something you guys would be interested in? And he was like, yeah, let's start to like file, let me help you get this grant going. Let's scope it out together and then you can submit it and it should, we should be able to get it approved because, we knew the right people at that point. But the amount of paperwork to deal with like the Bill and Melinda Gates Foundation was not like trivial. It's not the same as just like, filing for like an SBIR or something like that. That's not easy either. By any means, but dealing with that level of stringency and bookkeeping, like you had to like, every time you spent something, you had to like, this was for the grant. This is like, and then all of a sudden you're like, well, I'm buying a pack of test tubes. Like, do I have to tell you how many test tubes from that pack are being used for this grant and this one? So the amount of bookkeeping and paperwork was a lot. Filing the grant itself was quite intense. But we filed that ourselves, but it really helped that we knew somebody working there. If not, I think it would have been maybe just kind of throwing another grant across somebody's desk and hoping that they found it interesting. So maybe my recommendation is to like the granting agency, like ask them what are they looking for? Like so that you can like try to make sure your application lines up with the things that they're already trying to solve. So you can like take what you're trying to solve and write it in light of what they're looking for so that they see that, oh, by funding this project, it will solve X, Y, and Z for us. So I think that that's really important. And that goes the same way if you're looking to do like a joint development agreement with a established large company, right? So we have one project with the Wonderful Company. They own the Palm brand. So if you've ever bought pomegranate juice at the store, it has that kind of like round bottle. They do that. And we saw that they were looking for innovative ideas on how to use up their waste streams. They have 50,000 tons of pomegranate waste every year. And so, we managed to find somebody at the company that would talk to us. And we kind of pitched them, well, what are the things you're trying to solve? What are the things that are like could come out of this like entrepreneurship challenge that would drive your business? And for them, it was really, how do we make ourselves more green? So like, let's not send our waste to landfills anymore. Let's try to do something with it. And number two, they were really health minded. The Palm brand has a ton of polyphenols and things like this, and people associate it with a healthy beverage to drink. So our pitch to them was, well, why don't we take your waste stream, break it down, and then add that fiber back into your beverages. So now you can have a beverage that has the same amount of fiber as a pomegranate, but it doesn't taste like it. It still tastes like the Palm beverage everybody loves. And so once we found what they were looking for, we were able to write the grant in light of that. And so we still have that partnership to this day, and we're starting to work towards commercial goals.
I don't know if you would know the answer to this question, but I'm curious if students are doing research outside state, and I'm not a student, I'm outside of this, like if they need help with grants, like I know there's a grant writing group department outside states too. I mean, how does that work? Does the university help the student scientists write grants? Maybe nobody knows. I'm just curious.
I don't necessarily have the answer, but I could maybe defer the answer. I don't know if Kathy, I know probably maybe the Office of Research, Innovation, and Economic Development would be that partner. I think they're on the second or third floor here. That's usually been the place, and we have stood up a technology transfer office now, which is helping in that process. So they would usually be the key driver for that. But I think part of it is a student connecting with faculty member on what that research might look like, and then they would use the university resources like the Office of Research, Innovation, Economic Development, or OREAD. And then,
Quick question regarding execution and operations. I know you being from UC Davis, and with all due respect to UC Davis, why did you select students from Sac State? And I may have a similar situation, not to bring in the library into account, but I just, from practical application, I have probably ran into a similar situation just based on how the university systems are structured compared to UC system versus the state system. Share your experience.
So I think that my experience might not be the answer you're looking for, but I hired two new people. One was from Davis, one was from Sac State. But the student from Sac State, you know, we were looking for people that knew carbohydrate chemistry, and it's kind of a rare field to be in. There's just not a lot of labs that do this, and so when a resume came across my desk that this student knew what certain sugars were called and had worked with, synthesizing these things, it was like immediately like, oh wow, like this is what we're looking for. And this was one of Kathy's students. And even at Davis, there's really only 2 labs I know that really focus on carbohydrate chemistry. And I think there's one at Sac State. Is there more than one?
There's 2, but one's definitely on the analytical side.
Okay.
Yeah.
So yeah, there's just not a lot out there. So when I saw this come across my desk, it was really great. But one of the things we were talking about earlier is that you mentioned to me that something like 65% of Sac State students end up staying in the area. And I think that this might be the reason why, as we've grown the company, we now have more Sac State graduates than UC Davis graduates. Because I think a lot of the folks from UC Davis end up, they came to Davis from somewhere else and then they go back home. So it's, people going back to Southern California, people going back to the Bay Area, whereas Sac State, I think it's a lot more people from the Northern California, Sacramento region, and those people graduate and they want to stay here and they want to find jobs in their field and things like that. And like biotech and food tech in the Sacramento area is actually like blowing up like crazy right now, especially as like the price of lab space and things like that gets like really crazy in the Bay Area, like 8 times the cost per square foot. So you see a lot more companies coming inland.
So I have 2 questions. Actually, yeah, we're both students from UC Davis doing research. So like one of the challenges I think we're having right now too is like you mentioned before, like you're looking for grants and you're trying to find grants, Gates Foundation. But did you have any challenges of you're doing your current research as a graduate student, but then also it's conflicting with the goals of the grant that you receive at their goals as well, or you're with a goal?
So that grant we got from the Gates Foundation for the company was after I was no longer a student. So we started the company basically right when I graduated. But there was definitely times as a graduate student that I was working on things that were funding me that did not feel at the time like they were driving my personal goals forward. When we first started working with Mars, we pitched them this idea of food and the microbiome and things like that. And shockingly, they were not interested. It seemed like it'd be right up a food company's alley. Instead, they had been working on this project where there was this corn that grows in Oaxaca, Mexico that has these like aerial roots that come off that are just like covered in this like thick jelly mucilage. And it turns out that they were discovering that there was nitrogen fixing bacteria that lived in that mucilage that made it so that corn did not require fertilizer. It was just pulling nitrogen from the air to grow. And we were actually tasked by Mars to figure out, well, what's that mucilage made out of? And that mucilage was made out of carbohydrates. It was made out of fibers. So we were able to use that funding from Mars to develop the analytical tools that we still use today at the company. So even though like at the time, it really felt like, hey, I don't want to be studying this corn mucilage and nitrogen fixing bacteria. That's not where I want to go. But the time spent studying that really enabled us to push the actual goals further. So if you're working on a project right now that doesn't necessarily feel like it's what you want to be doing. Try to think about what are the points of that project that will be able to help you reach your own goals, right? So like maybe there's a part of it that like is going to be translatable to something that you're interested in, or a technique that you can develop there that you'll be able to apply in your own kind of personal endeavors.
Sorry.
Yeah, no.
Quick follow-up. When you were discovering up your customer bases, I noticed that it kind of evolved over time. So did it just grow, or did you have to keep shifting to find like you should target?
So the biggest thing we had to do is listen, right? Like we had to like recognize that it's really easy to think you know what the market wants, but you really have to like listen to what the market wants. And the way that we did that was having as many conversations as we could with companies that we thought would be our customers. So we would go to trade shows, we would try to get people to hop on a Zoom call with us, and we would just start asking them questions. This whole concept of like circular economy with Palm, for example, and their waste streams, it was never part of our business model to try to go make the food system more green. But all of a sudden, when we started talking to these companies, we started thinking, well, maybe we should be making fiber out of waste streams. The funniest thing about it is actually, you know, once the food industry pulls out all the starch and all the protein and all the sugar, basically what's left is fiber. So that meant that we didn't have to pull out all the starch and all the sugar and all the protein. So it actually made our lives easier. But now I'd say that more than half of our partnerships are helping upcycle waste streams. So, you know, it was never part of our vision, but we just listened to what our customers wanted. And that's one of the things that was really important to them.
We have time for maybe one additional question. Yeah, Lisa.
Have you reached a point, or do you imagine a point where you want to sit down and do the deep thinking on the next, like, big question? Or do you see yourself staying, like, there's enough still to explore in this area for you to feel satisfied as both science and standalone?
I think that, number one, I wish I had the time to do the deep thinking. No, I think all the way back to undergrad when I said that I had started doing undergraduate research and I had fallen in love with it, but I didn't quite understand what research was. And I just knew I had to go to grad school in order to like follow that path. Like I still very much feel in that position right now with building a company where it's like, I've gotten a little bit of a taste of what it takes to build a company and what it takes to make a product. But like every time I think I'm starting to understand that, there's just like something else past that is just like totally gets my mind turned around. And so for the last 2 years, it's been scaling up in engineering. I've never taken an engineering class in my life, but seeing the problems and seeing how they get solved has just like enamored me and like trying to learn as much as I can about this. And now it's starting to transition to actually how to sell a product and how to line up a manufacturing facility and how to do all of these things. So maybe one day, but I think I'll be focusing on this for a long time.
Any last ones? All right. So last question for you. Anything I didn't ask that you want to share with our group here? And then secondly is what can we as a community do to support you?
I think that I don't really have much that I think should be asked, but I would just recommend that if you do have like an idea, don't feel like it needs to be a secret, right? I think a lot of times people get an idea and they think if I tell this to somebody, they're going to go steal that idea or something like that. But really the ability to go out and actually talk to people about it will help you kind of hone that idea better and better and better, because people are going to ask you questions and you're like, oh man, like I never thought about that before. And then you just get a little sharper and somebody else will have a recommendation and it'll just make you a little sharper. So don't be afraid to talk about things. There's always a little bit of secret sauce you can't talk about, but you know, I think that that's actually more rare than people think it is.
All righty, let's give it up for Matt here today. Awesome. Thank you all.